So we learned about definite integrals, and now we have indefinite integrals, and the difference between them is the limits of integration. So the definite integral has the a and b limits of integration on the integral sign. The indefinite integral does not have that, and it says here the integral of f of x dx is traditionally used for an antiderivative and is called, an indefinite integral. So we can say that the integral of f of x dx is equal to cap f, the antiderivative. And the fact that the integral of little f equals cap f, and notice again there's no a and b on the integral sign, no limits of integration, that means that if you take the derivative of cap f, you get little f. Now we have here a table of indefinite integrals, and as it mentions down below, you can verify these formulas by taking the derivative of any of the right-hand side of the equal sign. So for example, I'll just pick this one. If I were to take the derivative with respect to x of what's on the right side of the equal sign, then I'm going to get cosine x, right? The derivative of sine x is cos x, and the derivative of the added constant c is 0, and that is my integrand here. So just a reminder of the vocabulary. The integrand is the function inside the integral sign, not including the dx. The dx is not considered part of the integrand. And so any of these formulas in this table of indefinite integrals, you can check out for yourself. Take the derivative of what's to the right of the equal sign, and you'll get back the integrand. Now notice that all of these indefinite integrals have the plus c on them, so they are the whole family of antiderivatives. Now, as it says at the bottom of the page here, make sure you understand the difference between a definite and an indefinite integral. The definite integral has the limits of integration a and b, and the answer to that is a number. It is an amount of area between f and the horizontal axis on the interval from a to b. The indefinite integral that does not have the limits of integration is a function or a family of functions, so it's some formula, right? And they are related by that evaluation theorem. So if we integrate little f from a to b, here's some other notation. We can take our indefinite integral and we sort of say we're evaluating it from a to b. That's how I would read that. All right, so let's do some examples. And here's again some more reading for you to do, starting with example 5 on page 359 and example 7 on page 362. But okay, so we want to integrate x squared minus 3 from -2 to 3. So what I need to do, and this is following what we just looked at the bottom of the previous page, I need an antiderivative for x squared minus 3. So remember now, we have to twist our brains. The antiderivative, we add 1 to the power and divide by that new power. And although the derivative of 3 is 0, the antiderivative 3 is 3x. And so what I do is I take this antiderivative and I put it in parentheses, and then I put my limits of integration on the bar on the right-hand side, and that's the way it was written at the bottom of the previous page. Now remember that the evaluation theorem said I could use any antiderivative, so when I'm doing these definite integrals, the antiderivative that I choose to work with is the one that has constant 0 because it's the easiest. If I have a non-zero constant, I can use it, I can work with it, I can get the same answer, but it just adds a little bit of a pain to the whole thing. It's just a few extra steps. Okay, now how does this work? When I have this antiderivative and as I read this, I say evaluated from -2 to 3. So I take the top number and I plug it in for x, and then I subtract, take the bottom number and plug that in for x, and that's the way it works. So in the first case, I actually get 0. 3 cubed over 3 is 9, minus 9 is 0. And I wouldn't skip steps here. I'd be careful with your signs. You know, you might be tempted to kind of do more than one thing at a time. I don't recommend it. Negative 2 cubed is negative 8 over 3. Now I have a plus 6. And I want to put everything in thirds. So 6 is 18 thirds. 18 minus 8 is positive 10, but I have the negative on the outside. So apparently the answer to this definite integral, so again, remember the result of a definite integral is a number. Let's think about this graphically, because I got a negative answer, but this is supposed to be area under a curve. So x squared minus 3 is like our friend y equal x squared, but shifted down 3 units. And I'm integrating from negative 2 to 3. My drawing is not spot on accurate, but it's pretty good. So what this means, what I just found, is that when I take these two pieces of positive area and combine them with what I consider to be this negative area, the area under the horizontal axis, that nets out to a negative 10 thirds. Now I realize from my drawing it doesn't look like the black area is more, or is less, than the orange area, but that's just because my drawing skills are poor. And if you were to graph this on a calculator or a computer, you should see that the amount of orange area is more than the combined amount of black area, which is why the net result, the answer to the integral, is a negative number. So there was more area under the horizontal axis than above in this case.